black body radiation, which were not able to explain like these phenomena if we consider wave electromagnetic radiation as a wave, right? So now Planck came into the picture and he like tells everyone electromagnetic radiation is particle. Okay, so now we will talk about how electromagnetic radiation can act as a particle. Okay,
Okay.
now we are going to consider electromagnetic radiation as particle. So particle nature of electromagnetic theory, it's also known as Planck's quantum theory. It was given in 1900s, right, by Max Planck. So in the previous theory, the radiant energy was considered as continuous. Okay, so here Planck pointed out that radiant energy is emitted or absorbed is not continuous but discontinuous in the form of small packets of energy, and these small packets are called quanta. In case of light, quanta is photons, right? So if the radiant energy is emitted from any source or absorbed, it is in discontinuous manner, okay? And and in the form of small packets, which is called photons. Is this clear? What he
Can you
modified in
explain
the
with an
theory?
example?
For an example, suppose we are talking in terms of energy, right?
Yeah.
And discontinuous. If I am saying the energy is continuous, then this means I can take any value for energy. Suppose from 1 to 100, right? For from 1
Okay.
to 100, I can take any value for energy if I am like denoting it as continuous. But in actual, we observe that the electromagnetic radiation that we like experience have certain values for energy. It do not have all the values from 1 to 100. It has some specific values like 2, 3, 4, 2, 4, 6, are specific values for energy, not continuous. Is it making sense? With that example also, like take
Yeah.
continue. Is it clear? What do we mean by continuous? Continuous means we are considering all the possible values for energy. But when we are talking about discontinuous energy, we are saying that the electromagnetic radiation has specific energy. It could be 2, 4, but it is not continuous. Okay.
Okay.
The energy of each quanta, like quanta is basically
What is quanta again?
quanta is small packet of energy. Like in if you talk about specifically light, the quanta are photons.
Oh, okay, okay.
Okay. So the energy of each quanta, that means photons in terms of light, is directly proportional to the frequency. So we can say energy is directly proportional to frequency. And if we have to
Yeah.
replace our proportionality sign, we will introduce some constant. And here this constant is Planck's constant. It is a very important formula. We will do some questions about it. Okay, okay, okay.
Okay.
We haven't opened our camera. So I would request you to please open your front camera. I forgot.
Yes.
So
Okay.
this is, yeah, this is what? This is energy relation with frequency. And this was given by who? Planck, right?
Hmm.
And the Planck constant has a specific value, a constant value, which is 6.626 into 10 to the power minus 34 joule second, right?
Yeah.
The amount of energy emitted or absorbed is a whole number of quanta. So if you have been asked, like calculate the number of photons, so you can introduce this n and you can calculate it for the number of photons. Suppose you have electromagnetic radiation. In that electromagnetic radiation, there will be several number of photons because only one photon won't be able to produce like electromagnetic radiation, right? Electromagnetic radiation, we have several photons. So if somebody asks you, we have this electromagnetic radiation and calculate the number of photons present inside it, you will use this formula. You will introduce this n and you will calculate it, right? So
Yes.
far we have talked about these two formulas and they are pretty simple.
So where do we use E is equal to H into mu, and where do we use E is equal to NH mu?
Uh, it would depend on the question. Suppose question is asking you calculate the number of photons, right? So you will use this
Yeah.
formula, this n1. And if the question
And
is saying The photon is one, or it hasn't talked about number of photons. So you will simply use this formula and you will take n is equal to 1. We will do some questions
Proton is one.
if they are asking about energy. We will do some questions now. You will be able to understand it better. So I will discuss it where we are using this formula and that formula. Okay. For
Okay.
now, how we derive this formula, is this clear?
Yeah.
Right. So we talked about black body radiation, and black body radiation was a limitation of our wave theory. So now we will talk a little about how Planck was able to explain black body radiation, right?
Okay.
The substance with high melting point is heated. It first become red, then yellow, finally glow with white blue color. Suppose you are heating any substance, right? You must observe a change in color. Starting, it usually have red color, then you heat it more. Then it changes to yellow, then finally glow with white or bluish type of color, right? Have you
If you
observed
burn what?
anything? If you have something, you are burning it. Suppose you have a candle, right?
Okay, let's.
Take an
Okay.
example of candle. The candle, the thread part, the lower part of the
Mm,
candle has a yellowish type of color, right?
I guess, yeah.
And the top part, the layering top type of part has a blue color. And if you have to measure the temperature, you will see the blue color has higher temperature and this yellowish part has lower temperature. So if we like relate it with a substance, suppose you are having a black body and you are heating it, it will first glow as a red color because suppose we have frequencies wavelengths. The longest wavelength is for which color?
Longest wavelength.
Yes,
Is it red?
yes. And lowest wavelength is for violet,
Violet.
right? Suppose, if I'm talking in terms of energy, if something has highest wavelength, the energy should be, if I relate it with this formula, we have h mu, and I can write it like hc by lambda, right? If the wavelength is highest, the energy will be, it is inversely related. So if energy is highest, so wavelength will be least. If the wavelength is highest, then energy will be least. Inverse
Hmm.
means, right? What about
There's two
violet?
constants in one equation. Can we do that?
We can introduce two constant in one equation, but at your level, you won't be able to deal with them. You won't have to deal with them because, like, if you are introducing two constant, then the calculation become a bit difficult or complicated because you have to solve for
Mm.
both of them. If you have to find, like here, you can introduce. You have specific values now. You know the value for h, you know the value for c, so you can introduce here. But if
Yeah.
somebody asks you, that's a different case. For now, you can introduce two constant at a time. Okay. These two are constant. H is constant and C is also constant. Is it clear
Yeah.
about your question constant part? Yeah. Now, if I am talking about the energy for red color wavelength, the energy will be least or not?
It's gonna red color, right?
Yes, red color has the highest wavelength. But if I
Yeah.
talk in terms of energy, it will have least energy.
Least energy, yes.
Are you able to relate it with this formula?
Yeah.
Because, right, if I am talking about violet color, again, we will use this formula. If the lambda is least, then the energy will be highest. Now, keep this in mind and try to connect it with this. Suppose you have just started to heat a substance. Let it be a black body, right? You have just started. At the initial stage, the black body is absorbing less amount of energy. Like it is not that much heated because you have just started heating it, right? So it will start
Heating
with,
the black body.
if you are heating a black body, you have just started heating it. The black body is not experiencing that much of heat, right?
Okay.
Then it will start by like emitting red color because red color has least energy. And the moment you have
Yeah.
started, the black body is observing least energy, right? Least heat thermal energy. But as you
Yeah.
are going ahead, as you are heating it for like few minutes or few hours, then
It'll go to violet.
it will start to absorb more and more energy. And as it is absorbing more and more energy, the wavelength will shift from lower energy to higher energy. And if it is shifting from lower energy to higher energy, then the wavelength will also shift from lower wavelength,
No, wait.
sorry, from higher.
Isn't it wavelength moving from higher
Higher to lower.
wavelength to lowest
Yes, yes.
wavelength, and energy is
Wavelength is,
going from lowest to highest?
yes, that's the case.
Okay.
Because the wavelength is changing in terms of energy, we are observing change in color as well,
Okay.
right? But what did wave theory considered? Wave theory considered continuous, so we should have observed the same color, right? So this was its limitation. Now we will talk about how Planck was able to like clear this issue. First of all, he considered wave as discontinuous, right? Radiant energy is discontinuous, not continuous. So we will talk about that. Just be with me for. If a substance being heated is black body, this we already talked about. It will emit and absorb radiation, right?
Mhm.
According to wave theory now. According to wave theory, the energy emitted or absorbed continuously. As per wave theory, energy is emitted or absorbed continuously, right? It is proportional to intensity and independent of frequency and wavelength. If we considered electromagnetic radiation as wave, then these are the things that we should follow. It should be continuous and the proportional to intensity and incident frequency and
What should
wavelength.
be continuous?
The radiant energy. If we talked about wave theory, Maxwell considered the radiation as continuous,
Yeah.
but Planck considered the radiation as discontinuous, right?
So Maxwell said that the radiation is continuous,
Yes, this was the
but
reason he
Planck
was.
is opposing that.
Yes, Planck is saying it is discontinuous, and due to this point, Planck was able to explain this black body radiation. Because if we consider the electromagnetic radiation as continuous, then we will observe a what we call that ultravioletic catastrophe kind of phenomena that you don't have to go through. I will just give you a brief about it. What happens if we consider it continuous? Then this graph that we are observing here, it would look like this. It's a quantum mechanical phenomena. The graph will go to infinity. If we consider this continuous, then it will observe a ultraviolet catastrophe. I don't know. I am
What
pronouncing
is
right or not.
T?
T is temperature. I will come to it.
Temperature.
Just give me a minute. Okay. The radiation being heated should have same color. See, try to connect it. And if you are not understanding, I will like tell you again and again. Just ask. According to wave theory, the energy is
Mm-hmm.
continuous, right?
Mm-hmm.
If it is continuous, it should be proportional to intensity. It should be proportional to intensity and independent to frequency and wavelength. Is it clear till here?
Proportional to intensity. What's
Only
intensity?
intensity of energy, like the electromagnetic radiation, how intense the electromagnetic radiation is,
Okay.
right?
Proportional to
To intensity only
intensity.
and independent.
Dependent of frequency. What does that mean?
Independent.
Dependent.
Independent.
Independent. Okay. So it
This
doesn't
means
depends on frequency and wavelength.
it should not depend on frequency and wavelength. If we are considering waves, then it should only depend on intensity and not on frequency and wavelength, as per wave
Okay.
theory. Now, the radiation being heated should have same color. If we are heating a black body, then it should emit only one color. But while we practically do it, do we observe this? We observe different colors, right?
Yeah.
So if we are considering it as wave, then it should have same color. So this was not practical. So Maxwell failed. Although its intensity may vary for as we heat to its continuous, but the change color show that on heating the frequency radiation increases from red to blue. And this was explained if we take energy, radiant energy as discontinuous, right? If we are taking radiant energy as discontinuous, then we will observe this graph. Let us talk about this. This is intensity and this is wavelength.
Mm.
As I am moving from left to right, what is happening? Wavelength is increasing and intensity is also increasing to a certain point,
Yeah.
this maximum point, then it decreases, right? Now, let us try to understand it with respect to temperature as well. Suppose,
So if there's a lot of intense energy is applied on an body, the the heat, the temperature also increases a lot, right?
we will come to that. For now, you should only see intensity and wavelength. Then we will merge temperature. First, talk about intensity and wavelength. Intensity is
Okay.
increasing with increase in wavelength,
Yeah.
right? Now, let us merge temperature to it. T1 is highest, then T2, then T3. Now, if we talk about this, suppose we are moving
Mm.
from right to left. As we are
Okay.
moving from right to left, the temperature is decreasing or increasing. Temperature is increasing, right? Because
Increasing.
T3, right. As the temperature is increasing, what is happening to wavelength?
Wavelength.
Yes. As we are moving from right to left, temperature is increasing. You told me. Wavelength is decreasing. You can see
Yeah.
as we are moving from left to
Yeah.
right.
Wavelength is decreasing. Yes.
Wait. Now, as we are increasing the temperature, the wavelength is
Decreasing.
decreasing, decreasing, and the intensity is increasing.
Yes.
So this is the reason, for example, suppose we have here the temperature is zero. Take it as zero, right? As I am heating it, the temperature is increasing and the wavelength is increasing. That means the energy is more. As I am moving from right to left, the energy is increasing as the temperature is increasing. As the energy is
Yeah.
increasing, intensity will also increase. Intensity will also increase, right?
So energy is say that again. Sorry.
No issues, no issues. This is a bit complicated because we are talking in terms of quantum mechanics here. Suppose as I am moving from left to right, the temperature is
Okay.
increasing
Temperature is increasing. Yes.
and wavelength is
Decreasing.
and
Right to
energy will
left.
also increase.
Yeah.
And as the energy is increasing, intensity will also increase.
Yes.
Now, in the initial stage, this is not emitting any color because temperature is zero. But the moment we started heating, as we are moving from left to right, it starts to show color. Suppose this is region here, this region. In this region, the electromagnetic radiation that we are observing are ultraviolet, and that's why we are not able to see it with our naked eyes. But the moment it reaches here, this region, we are able to observe the color. This peaks, this peaks we are observing here now. These peaks are showing
Left to right or right to
right
left?
to left, right to left. At highest color, at highest temperature. This is the highest temperature from right to left, right?
Yeah.
At the highest temperature, the intensity is highest.
Yes. The
As the
intensity is highest.
as the intensity is highest, from this
Energy
peak
is the highest.
energy is highest. From this region, we are able to see the color because this is the region of visible spectrum.
Okay.
So this was all about our black body radiation. How he solved it? He solved this by considering our wave as, considering our electromagnetic radiation as discontinuous.
And where is it not visible?
Here, here, the moment we started hitting it now, it is
Oh,
in longer
started to
wavelength.
heating. It's not visible, but
As
going.
we are,
Why is it
yes,
going reversed? Right to left.
we are going right to left because from right to left, we are talking in terms of temperature.
Okay.
Temperature. You can go to left to right, but it would make it a bit complicated because then we will have to talk in order of decreasing temperature. That will make things complicated.
Okay, I understand.
Let me give you a like summary. What is happening here? Just give some detail. See, as we are moving from left to right, temperature is increasing. As the temperature is
Mhm.
increasing, the substance is having more and more energy. As the energy is increasing, the intensity is increasing. At the
Mm.
initial stages, the this region has longer wavelength or not? This region has longer wavelength.
Yeah.
Longer wavelength means low frequency.
Low frequency, temperature, and energy.
So here we will talk about UV, ultraviolet, and we can't see ultraviolet, right? Ultraviolet radiation we cannot see.
Yeah. We
So
cannot see.
the moment it reaches this region, we are able to see the color. Suppose this is the lowest temperature. At the lowest temperature, it would appear as red. And as we are
Mm.
moving ahead,
That's
we will
blue.
observe the blue color, the violet color type, right? The highest frequency.
Okay. What about
Now,
in middle? T2.
in middle, we will like we have a Vibgyor kind of thing now. Vibgyor.
Vibgyor.
So we will yellowish type of color,
Okay.
yellowish orange type. So let us talk about the features this graph is showing us. At a given temperature, intensity increases with increase in wavelength, reaches the maximum value, then start decreasing. As intensity is increasing, wavelength is decreasing, it reaches a
Hmm.
maximum point, then it starts to decrease. At higher temperature, what is happening? The peak shift to lower wavelength at higher temperature at T1. What is happening? The peak is shifting to lower wavelength, right? From right to left, lower wavelength for T1.
Yeah.
The maximum intensity increases, the curve becomes broader or higher. Out of these three curves, the blue one, the violet one, and the red one, which curve is broad, the most broad? T1, it has the most area under it for T1, right?
Yes.
Then T2, then T1, T3, sorry. Okay, let's talk about graphical trend as well. At lower temperature, the peak of the curve lies in longer wavelength infrared region. The intensity is low. As the temperature increases, the peak shift to shorter wavelength, visible or UV region. The overall intensity increases sharply. The area under the curve, total energy increases with temperature. The thing I have told you, this is all written here, right?
Okay.
Physical interpretation, higher temperature causes the black body to emit more and more energy per unit area. The emission effect towards higher energy, shorter wavelength. That's the thing. From right to left, energy increases. So from here,
Yeah.
they might ask you a case study based question, right? They won't tell you to write a note on black body radiation. They will ask you in terms of case study. So if you just
Case
give it to
study.
read, na, then you will be able to answer it. Case study type of question will be coming from this topic. So is it clear?
Yeah.
So how Planck was able to solve this issue? By considering energy as discontinuous. Okay.
Okay.
Now, this is very important because we have several numericals on this topic. Photoelectric effect. In 1905, after the discovery of this Planck quantum theory, the Planck quantum theory was discovered in 1900. After 5 years, Einstein came and solved this photoelectric effect phenomena issue. Right. So first, let us understand what is photoelectric effect. Do you have any idea what is photoelectric effect? Have you done it in your junior classes? Any idea?
No. No.
Okay. So let us talk about it. You have a metal surface, right?
Yeah.
And suppose electromagnetic radiation are falling onto the surface.
Okay.
So if we talk about photoelectric effect is if a radiation with certain minimum frequency falls on the metal surface and eject electrons. The ejected electrons are called photoelectrons, and this whole process of ejecting electron by electromagnetic radiation is called photoelectric effect. So what is photoelectric effect? The effect when electromagnetic radiation falls onto the metal surface
Falls on a metal surface.
and ejects some
Ejects.
electrons.
Reflects or ejects? What
Ejects some
does
electrons.
ejects mean?
Ejects means like you are ejecting it. In movies, you must have heard like we are ejecting from the plane, like somebody presses a
Oh
button
yeah,
and
yeah, yeah.
that ejects.
Okay.
right? So this is how a photoelectric effect looks like. This is our light electromagnetic radiation. It is falling onto the metal surface. It is ejecting some electron, and this ejected electron is being pulled by this positive anode,
With
right?
low frequency?
Frequency will depend. We have to use threshold frequency. I will talk about what is threshold frequency.
Okay.
Threshold frequency is the minimum frequency required to eject an electron.
Okay.
Suppose, let us take a general example. First, let me teach you what is threshold frequency, then we will take a general example. Photoelectrons are ejected only if the radiation has a certain frequency, that is threshold frequency. If the radiant energy do not have this threshold frequency, then there will be no photoelectric effect, right? So what is threshold frequency? The minimum frequency of radiation which is required to eject a photoelectron is called threshold frequency. Below threshold frequency, photoelectric effect is not observed. And how we will denote this threshold frequency? We will denote it by mu naught
So, threshold frequency is the minimum frequency required to
to eject
eject
an
the electron from
metal
radiation,
surface from
or
a metal surface.
going towards the metal surface, falling on metal surface.
Good,
Okay.
good, good. Just let us clear this as well. Here we have attached a battery. So what is the role of this battery? A battery will apply some voltage, will create some voltage, right? Due
Yeah.
to this voltage, there will be a positive and negative charge electrodes. So this
Mm-hmm.
positive charge will attract this electron. Suppose you have just knocked some electron out of this metal surface. You have just knocked some electron. So these
Okay.
electrons are suspended into this atmosphere. If you are not applying the potential, they will remain here. So if you are applying some potential, they will move from this point to the other point, to this positive end. And if a electron is moving, what is happening? If we move an electron, uh, what is happening if we move an electron? If electron moves, they will produce some electric current, right?
Yeah,
So
because
uh,
energy is getting released.
good, good, good. So if an electron is moving here, if we use a specific term, these are photoelectrons. If these photoelectrons are moving, the current that is produced due to the movement of photoelectrons are called photoelectric current. We will talk about that.
Okay.
Okay. Now, this last term, then we will take a general example. The minimum energy required to eject an electron is called work function. The minimum frequency is threshold frequency, and the minimum energy is called work function. And work function is denoted by W naught. Work function is basically energy, right?
Say that again.
The minimum energy. The minimum energy.
Mm,
Suppose the minimum energy to eject a electron from this metal surface. The minimum
okay.
energy required to eject a electron from this metal surface is called work function, right?
Work function.
And what is work function? Basically energy. And till now, what we studied about energy, we talked it like this now. Energy is nothing but Hc,
Yeah. FV mu.
h mu, right? So now, if we are denoting this energy as work function, we will use W naught. And if we are
Mhm.
talking about W naught, the frequency that we will use is going to be what? Threshold frequency,
Threshold frequency.
because
H.
minimum,
And what is that? O? Is that O? What is that?
it is not. Just to differentiate
Not.
normal frequency with threshold frequency.
Okay.
Okay, now let us understand with a general example what is happening. Give me. See, what do we mean by threshold frequency, minimum frequency, and what do we mean by minimum energy? Let us understand with a real life example. Suppose we have wrestlers. Pick three wrestlers.
Mm-hmm.
Pick any three wrestlers.
I don't watch wrestlers, so I'll just imagine some wrestlers.
Okay, okay. Do you know Undertaker?
Um,
Okay.
I don't know.
Any
Thomas
superhero,
Edison.
any superhero, Superman or Anyway,
Okay, Spider-Man, I guess.
Spider-Man or C. We have to take
Iron Man.
Iron Man. Okay. And
Doom.
okay, Doctor Doom. Okay. Now, suppose, if I am hitting Spider-Man, if I am punching
Mm,
him, and I need
mm,
him to move, or I need him like, suppose this is Spider-Man and I am hitting him. So if
mm.
I need him to move, like move backwards or anyway, I need a movement from him, right? So the
Yeah,
punch that I'm hitting him with should have sufficient energy, right?
yeah,
Suppose I am hitting Spider-Man. Will he move? He will not move because I am weak in comparison to him, right?
yeah.
So if I am emitting some energy which do not have sufficient energy, then the metal will not respond. And in terms of this Spider-Man and Superman stuff, they will not move. They will not even flinch, right?
Yes.
Suppose Spider-Man has 10 energy, Iron Man has 8 energy, and this Doctor Doom has 5 energy. If I
Okay.
have to make Spider-Man flinch, then I have to apply at least 10 amount of energy. For Iron Man,
Yes.
8. For Doctor Doom, 5. So the minimum amount of energy that I need for Spider-Man to flinch is 10, right? And this minimum
Yes.
energy is what? Work function.
Okay.
And inside this energy is of what? Energy has frequency, right? If I am expanding this formula for energy, I can write it like h mu.
Yes.
And if I am talking about minimum energy, the frequency will also be minimum. And the minimum
Mhm.
frequency denoted by what?
Uh,
Mu naught.
H mu.
No.
Oh yeah, minimum frequency. Yes.
So is it clear or should I take some another example?
No, no, that's clear. So much clear.
Okay. Now, we'll talk about a
Mhm.
new kinetic energy term. Then we will have to
Mm,
come back to this example. So wait for a while.
mm.
Now, let us talk about some characteristic of photoelectric effect. Number of photoelectrons ejected is directly proportional to intensity of light. Let us understand what do we mean. The number of photoelectrons ejected is directly proportional to intensity of light. If the
Okay.
intensity of light is more, the number of photoelectrons ejected will be more. Suppose this metal surface has 100 electrons, right?
Mm.
If the intensity is low, then the ejected electron will be like 10. But as I am
Yeah.
increasing the intensity, the ejected electron will be more. Like suppose 100 out of 100, if I am increasing the intensity, 80 will eject. If I increase the intensity even more, all the hundreds will eject.
Okay.
Okay. Now, what is photoelectricity? Photoelectricity is the electricity which is produced by the movement of these photoelectrons or not.
If the moment.
Right? What are photoelectrons? Photoelectrons are electrons which are ejected by collision of photon and electron. Photoelectrons are normal
Collision
electrons.
of protons and electrons.
Photons. Light has photons, na? Quanta.
Yeah.
If
Collision. Oh, okay, 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 okay.
they are knocking the
Wait.
electrons out,
Then where does electrons come from?
electrons are inside the metals.
Inside the
Uh,
metals.
suppose sodium is a metal. Sodium
Yeah.
has electrons or not? Out total 11 electrons, and in outermost shell, how many? One, right?
Yeah.
So metal
Yes.
has its own electron. Suppose this is my like, am I visible or not?
Yes, you are.
Suppose we have this. See,
Mm-hmm.
this is a plane surface, and I have put it some white substance into it, right?
Okay.
It is attached to this metal. And if a photon is coming, if a electromagnetic radiation is coming, they will knock this electron from the surface, and the electrons will be in the environment, and this battery that
Okay,
we
it
have
gets
attached,
replaced.
it gets replaced. Basically, you can say that.
Okay. So the metal gets positively charged by
Good, good,
removing
good, good, good,
electrons.
good, good, good. Is it clear?
Yeah.
Now, see, this electron is ejected here,
Mm-hmm.
and it will be pulled by this positive charge or not? The positive
Yes.
charge, which is due to the potential. If the electron is moving from right to left, then the current will also be in the opposite direction.
Yes.
And the current produced by these photoelectrons is called photoelectric current.
Okay.
Now, we talked in terms of intensity. If the intensity is high, the number of electrons will be high. And if the number of photoelectrons are high, the photoelectric current will also be high, right?
So photoelectricity is proportional to intensity
Intensity.
then.
Great. Yes.
And intensity is proportional to the amount of electrons that is ejecting.
Great. Yes. Right.
So, okay.
Now, kinetic energy of photoelectrons varies from 0 to a max value depending upon the frequency of light, not the intensity of incident radiation. This is a very important statement. They will ask you several questions on this one statement. So what we need to understand here is just try to read it on your own for a few seconds, then I will explain.
Okay. Okay. I have question in this.
Yeah, go
So
ahead.
what is for okay, first of all, they're
Mhm.
adding photo to electricity, electrons, and one more. What does photo represent? What does photo mean?
Photo. Suppose we have photons, right? Photons are
Yeah.
inside the electromagnetic radiation. The moment these photons collide with electron and knock them out from the metal surface, the ejected
Mhm.
electron are termed
It's
as
called
photoelectrons.
photoelectrons.
Yes.
Okay.
Just a naming term, photo.
Okay. Okay.
Let me explain then. See,
Okay.
kinetic energy. What is kinetic energy?
Mm.
The energy which is produced by the movement of a substance, right?
Yeah.
The kinetic energy varies from 0 to max, and it depends
Mm.
on the frequency of light,
Frequency of light.
not on the intensity. If you are increasing the intensity, the number of ejected electron will increase. But if you need to increase the kinetic energy, you need to increase the frequency of that electromagnetic radiation. You have to increase the frequency of those photons which are emitting that electron, ejecting that electron. So is this point clear? If you are talking in terms of kinetic energy, then you need frequency. The only task of our intensity is to eject electron. After ejecting it, its work is complete. If you talk about kinetic energy, it's solely based on frequency. If the frequency is more, the kinetic energy will be more, right?
Okay. Yes. So amount of photoelectrons it depends on intensity, and the
Yes.
kinetic energy of photoelectrons it depends on
Frequency.
frequency of light,
Yes. Right.
or frequency of something that is emitting radiation.
Frequency of that electromagnetic radiation. Basically,
Yeah.
suppose we are we are like uh, passing some light,
X-ray.
any light, any electromagnetic radiation. This electromagnetic radiation's frequency will be the reason of the kinetic energy of the ejected electron, right?
Okay. Yes.
Now, this is important, very important. We will do few questions on this topic, so try to understand it. Ask as many questions if
Mm.
Any point is not clear. Energy supplied. The source of energy is what? Our
Source of
electromagnetic
energy.
radiation. Electromagnetic
Yeah.
radiation. Energy supplied is electromagnetic radiation.
Mm-hmm.
Energy required to eject electron is associated with what? Our metal.
Um. Okay. Yeah.
And the minimum energy required to eject the electron is what?
Work
V naught,
projection.
work function. Work function, right?
Yeah.
You know. And this is kinetic energy. So what we are saying
Yeah.
here is, if I am supplying electromagnetic radiation to a metal surface, it will convert into what? It will convert into the work function plus kinetic energy. How work function plus kinetic energy? Let us talk about this. Suppose, let me take that example of
So
Superman.
it's the total amount of energy supplied
Hmm.
used during that process.
How it is used? Some of the energy will be used to eject electron,
Yeah.
and some the extra energy will be converted into kinetic energy. Right?
To
Let me.
transport the electrons.
Good, good, good. Let us take that example back so that you can hold this information for a long period of time. I think if I see just as like your opinion, if I'm taking those kind of example, are they better or should I stick to the more scientific one
I mean, it depends on what it is.
for this
If
one?
it's
Like,
difficult, don't use scientific. But if it's simple to understand, use scientific.
is this simple to understand for you?
Yeah.
Okay, so we are not going to that. See what I'm talking about. This is my metal, right?
Mm-hmm. Mm-hmm.
This metal require 10 joules of energy. After receiving
Okay.
10 joules of energy, then only it will give some electron.
Okay.
The minimum energy is how much? 10 joules.
Yeah.
And the minimum energy is called what? Work function.
Work function. Yeah.
Now, I am supplying only 10 joules of energy. So then
Okay.
it will only eject the electron. There will be no kinetic energy.
So it will
Suppose,
only eject electrons.
and the electron will have no movement, no kinetic energy.
So electron is just flying over there, not even moving.
Yes, yes, yes. Good. So let us talk about cases. If the work function is high, suppose the metal required 10 joule of energy and you are supplying only
Mhm.
8 joule. Yeah, 9.5
8
joule.
joule.
9.5 or 9.9. Yeah, 9.8, right?
Okay.
So no photoelectrons will be ejected.
Actually, no. Wait, what?
Suppose
I mean, some of them can be ejected, bro.
no, none. If it
So
requires
if
10
it's
joule,
like little bit less than the required amount, nothing will be ejected.
no, no photoelectron, no photoelectric effect will be observed.
I thought if there's less, only little of electrons will be
No, no,
ejected.
no, none.
Okay, no
That's why I use
electrons.
this specific 9.5 because if I use 8, then you might consider like if we have a near value to 10, we can eject. No. If it is
No.
less, the metal will not give any electron. Metal is very sincere in terms of giving
Mm,
electron. Now, if you give him the minimum energy, then only it will eject. So if the
yeah.
energy of the radiation is less, then no electron will be,
Ejected.
and the kinetic energy will be zero.
Mm-hmm.
Now you are giving exactly 10. Our metal need 10. You are exactly giving it 10.
Electrons will be ejected only,
But
but kinetic energy is zero.
great. If the kinetic energy is zero, there is no movement. And if there is no movement,
Mm,
the photocurrent will be zero.
yeah.
Now,
Photocurrent. Oh yeah. Yeah. Current. Yeah.
basically, current. If our metal needs 10 and you are supplying
Mm-hmm.
15 or 11, then this
Mm-hmm.
one extra energy will be transferred to our kinetic energy.
Kinetic energy, but it's very slow.
Very slow. If you are, see, if it needs 10 and you are supplying 15, then the 5 will go. More kinetic energy, more movement, more photocurrent, right?
Yeah.
Is it clear?
Yes.
Let us do some questions. Okay, before that, let us talk about this last semester. What is stopping potential? The minimum potential of anode to reduce the kinetic energy of photoelectrons to zero. The potential that you need to apply so that the kinetic energy of the electron becomes zero is called stopping potential.
Why do you need that?
By studying the electron, if the electron is moving, you are not able to study it that proficiently. So if you stop it, you are
You need
able
to
to.
stop it.
And how can you stop it? By applying minimum potential, right?
Potential. Minimum
Yeah.
potential. Potential energy.
Yes. Let me give you how. See, this is battery.
Yeah.
The use of this battery is to supply some potential.
Yes.
So if I need to stop this electron, the potential that I need to apply is the lowest minimum potential.
Minimum. Okay, okay, okay. It's just
So
dialing down the volt. I mean, potential
uh, yes, yes.
to stop it or slow down, maybe.
Hmm. So let us summarize what we have studied so far in photoelectric effect. What is
Yeah.
photoelectric effect? The phenomenon of
Photoelectric
ejection.
is a phenomenon where radiation, magnetic radiation, is falling on a metal surface and ejects electrons
Very good.
with minimum required of energy and frequency.
Very good. Very good. Very good. Good. So let us do some question and
Mm.
wrap this photoelectric part. Do you have your NCRT with you?
No, I have to bring it.
Okay, bring your NCRT, then we'll do some questions.
Yes. Okay.
Go to
Page
this
number
page number 43. Problem number 2.6.
42.
43 or 42.
43.
Problem number 2.6.
It's 43.
Okay. Now, see, we need to calculate energy.
Problem number 2.6.
Yes.
Okay.
We need to calculate
Calculate
energy.
energy. Can I
Mhm.
read the question first?
Yeah. Go ahead.
Calculate energy of 1 mole of photons of radiation whose frequency is 5 into 10 to the power of 14 hertz.
Hmm. Right.
So, energy we need to find.
Energy of 1 mole. And what
One
is
mole of
1 mole?
photons. 1 mole.
Ah,
Um, 6.022 into 10 to the power of, uh, is it
23.
6?
23.
23.
Yeah. So
Okay.
first of all, we need to find the energy. So what is the formula for energy?
Energy. E into H mu.
Great. The frequency is given.
Yes.
So
5
we can
into 10 to the power of 14.
apply the formula. It is very simple, right? The value for Planck constant is constant 6.626
Zero. Yeah.
into
Into
10 to the
10
power
to the
minus
power of minus 34.
3 seconds. So I will apply this
Mm-hmm.
and the frequency is given.
5
The
into 10
answer
to the
is
power of 14.
3.313 into 10 to the power minus 19 joule. Just a note, this energy we have found here is for one photon
Isn't it
because
10 to the power of minus 20 joule?
it is minus 19. After solving this, we will get minus 19 joule.
Okay.
Okay. So the thing here is the energy found here is for one photon. How? Because in this formula we considered n as what? One.
Mm.
If you know the energy for one photon, can you calculate the energy for 1 mole of photon?
1 mole of photon.
Can you calculate it or not?
Divided by
No, no, no.
6.022
Multiply, multiply.
multiply.
Suppose, you are Zuhair, right?
Mm.
And Zuhair has 10 rupees. And I am
Mm.
asking how much money will 1 mole of Zuhair have? You will have to multiply it by that number, right?
Yeah.
So we will use multiplication here.
Oh, okay, okay. Yeah, I understood. I understood. Yeah, you need to multiply it. So
After
3.313 into 10 to the power of minus 19
into 1 mole.
into 6.2022 into 10 to the power of 23.
So after calculating it, we know the energy of 1 mole of photons. Is it clear?
Mm. Yeah.
In the final answer, they have converted into kilojoule, right? So you need to do the
Yes.
calculation on your own. That way you will be able to build the approach of solving the question. And please practice. Now
Okay.
this 2.7 question. This is a bit
Uh,
critical. You need to think about it. What is
okay.
given?
What is given? Power. Power is given.
What? Very good. Power is
Given.
100 watt.
Wavelength is given in nanometers.
Good. What we need to find?
Mm, okay. Calculate the number of photons emitted per second by the bulb.
So we need
Per
to find the number of
second.
photons per second.
Yeah. How do you do it per second? Is it frequency?
Per second means yes, we can say frequency, but we have to find the number of photons. So we won't go in that direction. Number of photon is not related to frequency, right? So what we have? We have power, which is what? Can we expand this watt? Watt is basically joules per second.
Power is what is the formula for power? I forgot.
Energy per unit time,
Okay.
right? So if I
Mm.
am talking in terms of SI unit, we can say joules per second or not. So the power is basically 100 joules per
100 per second.
joules per second. Okay.
Yeah.
Now, now we have wavelength. With the help of wavelength, we can find the energy for one photon or not. If I use this formula, E is equal to h mu,
H mu.
and I can write it like h c by lambda or
Yeah, that
not.
was the I was gonna say.
Good, good, good. 6.26 into 10 to the power minus 34 into 3 into 10 to the
3
power 8.
into 10 to the power of 8.
9. Right. After solving this, we will have this value, and I would request you to please do the calculation on your own without any calculator.
Yeah.
Right. Here we have what?
Energy
Of one photon.
of one proton.
Photon, photon,
Photon.
photon. Now, what else we can do?
What is photon?
Okay, we just talked about it, but see, we have energy. This is
Mm.
electromagnetic radiation, and
Mm.
as per Planck, this electromagnetic radiation has discontinuous energy, and consists
Oh,
of
okay, okay.
packets of energy, basically packets of energy. And these
Yeah.
packets of energy are
So
called
that those photons. Oh, I thought it was protons. I heard it
no,
as protons.
no, no, photons.
Photons or photons.
Energy of one photon we calculated. Now,
Mm.
for step 2, what we can do? For step 2, We need to basically find number of photons per second. If I have my power, which is joules per second, if I am dividing it with energy, which is joule.
Mm.
Now, if I do this, I can have number of photons per second. How? Let us see. The power is given how much? 100. And
Mm.
what is energy? Energy of one photon,
4.969 into 10 to the power of 18. Is it 18 or 19?
19, right? Second inverse. This was for one photon. So after solving this, we will have the value 2.012 into 10 to the power 20 second inverse. This means 2.012 into 10 to the power 20 photons are ejected per second if you apply 100 volt of power. Let me write it neatly. What does this mean? 2 into 10 to the power 20 photon per second are ejected if
How did it become 20?
20, like 2.02, I round it off to 2.
Okay.
If we apply 100 watt power. Is it clear? So from here
Yes.
we can have a new formula. N power divided by energy
Energy.
of one photon. With this formula, what we can find? Number of photon per second, because power is joule per second and energy of one
Yeah.
photon is joules. If we cut it out, we will get second inverse, and we are talking in terms of photons. So these are number of photons per second. Is it clear?
Yes.
Uh, this question is very frequent in any school exam. So please try to write it down right now. This one and the next example are very important, right? Try to write it down. And if at any step you are not able to understand, ask me.
Okay.
I can extend this class for like 15 more minutes now. Do you have any other classes after this? 10 to 15 minutes.
Um, I have school though tomorrow.
Okay, okay. No issue, no issue. We will do at 11:30.
If it's Thursday, I would accept it, but it's Tuesday.
Okay, okay. Thursday
I
we will.
mean, Wednesday.
No problem. I understand it.
No, it's Tuesday. Yeah. Can you scroll down a bit?
Yeah.
Just zoom out.
Just a second. Okay. Of one photon.
Not zoom in. Zoom out.
Okay, okay. So now
Yeah, that's enough. That's enough. That's enough.
the concepts are easy for to understand. I hope. Are you finding any difficulty at any point?
No,
Okay, good.
but remembering the formulas might be tricky.
The best trick to remember the formula is to do enough questions about that topic. Then it will automatically be embedded in your brain.
And knowing the constants too.
Like I
Planck's
told you now,
constant.
as you move ahead with your 11th now, you will remember this automatically because you will be doing so many questions and you will be using them again and again. So it will be automatically learned. This chapter and thermodynamics are the lengthiest. After this, the third chapter is pretty short, and the chemical
Wait,
bonding is the
I'm done, but I will check the portions real quick. I'll tell you them
yeah, yeah.
for upcoming. Chemistry exam is the first exam.
Okay, when
Monday, coming Monday.
uh how many chapters?
I'll tell you that right now. Chemistry only two chapters.
First and second.
The first two, yeah, the first two chapters.
On the next Monday. Today is Tuesday, I guess. Yeah,
Up
we
to
will cover.
shapes of atomic orbitals.
We will cover that. No problem. Just at your end, try to practice the question on your own. Okay,
Okay.
you will be able to score good. So, is this clear?
Okay.
Is this question clear?
Yeah.
Now, to the next one. Let us see. This one is interesting. See, what is the given data here? Try to tell me what is given.
In the third question, right?
2.8.
Yeah, just 1 minute, 1 minute. Okay. So 2.8. When the electromagnetic radiation wavelength is given as 300 into 10 to the power of minus 9 meters.
Mhm.
Surface of sodium. Sodium surface.
Okay,
Energy is kinetic energy of wait electrons are emitted with a kinetic energy of 1.68 into 10 to the power of 5 joules per mole.
good. What else?
Now they are asking us to find the minimum energy needed to remove electrons from the sodium.
Okay, so what is this minimum energy? It is work function or not?
Yeah, work function.
And what else they are asking?
Yeah, there's more. Um, then what is the maximum wavelength
Okay, lambda max. They
that
are
will
asking.
cause photoelectrons to be emitted?
So let us do it one by one. Okay. So first of all, we need to find work function, right? So what is the
Yeah,
formula where we can see work function? So it is basically energy supplied, which is E,
yeah,
work function plus kinetic energy, right?
yes.
Now, just so you can remember, this energy supplied is of radiation, the electromagnetic radiation. This work function is a property associated with the metal. Okay. These two are energies, but this is of electromagnetic radiation and this is of metal. Now, if I need to find work function, I need energy or not.
Mhm. Yeah,
And energy we can find with the help of this lambda. Energy of one photon we can find, right?
yeah.
So first of all, we need energy. Energy is what? Hc by lambda. And
Mm-hmm.
how do I know I am finding the energy of one photon? Because I am using this n as 1, right?
Yeah.
So here, if I put the value, right here,
9. That's 9
after
or 8?
solving, 10 to the power 9, minus 9, right? Yes, good.
Yeah.
Now, after solving this, I will get the value, which is 6.626 into 10 to the power minus 19 joule. This is what? Energy of
Energy of photons.
one photon. One photon.
One photon.
Now. Go back to the details. What was given? The kinetic energy is given for joule per mole.
Joule per mole.
And if we need to subtract anything, the unit should be in this formula. In this formula, we need to use kinetic energy here, which is
Yeah, which is 1.68 into 10 to the power of 5.
if I need to subtract it from energy of one photon, the
Mm-hmm.
energy of one photon should
Mm-hmm.
be of same unit, right?
Yeah, yeah.
But the energy we got here is energy of one photon, which is in joule. If we know the energy of one photon, can we calculate the energy of one mole of photon?
So we need to multiply this
With
to
Avogadro number
the yeah, Avogadro number 6.022.
into 10 to the power 23.
Yeah.
After solving this is the energy of one mole of photon, right?
Mm-hmm.
Joule per mole. Now you can use this because now the units are same and they will be subtracted. So we need to find work function, which is E minus kinetic energy. The energy of one mole of photon we calculated. I can round it off to 4, right?
Yes.
Minus the energy, kinetic energy given was how much? 1.68 into 10 to the power 5 joule per mole inverse. What we can do uh, if I write it like this and take 10 to the power 5 as common, is it correct or not? I can take the power as common or not,
Yeah, you can.
right? After solving this, how much I am going to get? 4 minus 1.68.
Um, 2.32.
Good. Into 10 to the power
5.
5. This is what? This is the
What?
minimum energy you need in order so the electron can get ejected from the metal surface. This is the minimum energy which is called work function as well, right? In joule
Yeah.
per mole. If you have
Now you need to find the wavelength.
maximum wavelength, right?
Yeah.
Just a question. Just a question. If I expand this formula W naught, how can I write it?
Um,
It is basically
work function is equal
hmm,
to HC
HC.
um divided by lambda.
Okay. Okay. See, you are correct. You are correct. Just see this
So
one.
we can
Second.
switch it as lambda is equal to HC divided by work function.
You will get the answer just so that you can understand the concept as well. Just try to check it. You are thinking the same thing or not? Right. We know what is work function. Basically, energy.
Yeah,
Energy is nothing
we
but
just
h mu.
found it.
Hmm. And if I'm talking about minimum energy, the frequency that I'm going to use is going to be minimum. And minimum frequency is what? Threshold frequency, right?
Um, yeah.
Now, the question is, we know lambda is nothing but c by lambda. Oh, frequency is nothing but c by lambda.
Mm-hmm.
Frequency is inversely proportional to lambda.
Mm.
If my frequency is minimum, my lambda will automatically be
Hi.
maximum, right?
Yeah.
So with this
But
reference,
isn't like intensity is also inversely proportional to lambda? So if
great.
intensity is low, the lambda will be high.
You can say that energy is inversely proportional to lambda as well. Great. You can do that as well. Is the concept clear how we used this work function to calculate the maximum wavelength?
Yeah.
So if you
But
put the
which one
value,
is easier? But you need to find the frequency, minimum frequency though. So that formula is much more easier.
This one is very easy. Basically, this is derived from here. Na? You just replace this. You just replace this
Yeah.
here. So both are same thing. I was just telling this, so there is nothing like I was just checking the concept is clear or not. It is clear for you. Good. So you will apply the values here and you will get your answer. The lambda is going to be 517 nanometer.
Mm.
Is there any step where you are not able to understand how this
No.
uh, is it simple?
Yeah.
So this was the like few of the most typical question that student like consider from this topic. If you are able to do this, back exercise and CRT question will be child's play for you.
Mm.
Right? So next
Yes.
question is 2.9. So what is given? Try to tell me first.
Okay. Okay. Um. So the minimum frequency is 7.0 into 10 to the power of 14
Okay,
s per second.
which is basically hertz.
Hertz. Okay.
What do we need to
Calculate
calculate?
kinetic energy of an
What is
electron
given?
emitted when radiation of the frequency is 1.0 into 10 to the power of 15
So
hertz.
the basic formula is what? Energy supplied is nothing but work function plus kinetic energy, right?
Yeah.
If we need to calculate kinetic energy, which is going to be E minus work function.
E minus work function.
Now, if I elaborate it a bit more, I can write it like h mu and work function
Hmm.
as h mu naught. Is it clear?
Wait, how?
See, we
E is
know
equal
energy.
to, yeah.
Is it clear?
Yeah, yeah.
Okay. I can take Planck constant as common.
Mm-hmm.
Now, a question. See, the last part. When radiation of frequency, the radiation of frequency, mu. This mu is the frequency of the radiation. And out of these two, which belong to the radiation, electromagnetic radiation, which is the energy of electromagnetic radiation out of E and work function.
Um, hmm. Which belongs to the
Radiation.
radiation, right?
Hmm,
Um, E
Great, good. And the other part, the mu naught
is the minimum.
is is the minimum frequency, and this is associated with a metal, right?
Yeah.
Now we know the values. We will simply put them and get a answer. Is it simple?
Yes. We have our frequency. Yes, we do. Um,
A question is coming up. Just try to focus. Okay.
yeah. Hmm.
Can I subtract it?
Huh?
Can I subtract this?
Yes.
Try to look it carefully.
Yes.
With the
But you
powers.
need, I know, you need to subtract those not subtract, divide those powers.
Mm,
How
no,
do
how
you
can
do
you
that?
divide it? No, no, no. We don't have to divide it. I told you na while I was teaching you
Oh yeah,
scientific.
yeah, yeah. Yeah. What if okay, 10 into 10 to the power of 14 minus
Good,
7
good,
into
good, good,
10
good,
to the
good,
power
good,
of 14.
good. How you did that? You just shifted the decimal point to the right, and if we are shifting the
Yeah.
decimal point to the right, we are subtracting power one. Good. These are the basics that you should always remember. Now the power is same. Now I can subtract it.
Mm. So it's 3 into 10 to the power of 14 into 6.626. So,
Our answer will be approximately 2.
hmm,
Is it clear?
Yeah.
All right. This was all about photoelectric effect. There are few more questions at the back exercise that I would request you to do as homework. Let me see which questions you need to do. Or I will assign them as your assignment. No, I will assign them. Let us move
Mm.
the next topic. Now, now, so far what we studied, electromagnetic radiation is wave.
Mm.
Maxwell was saying electromagnetic radiation is wave, and like Planck was saying electromagnetic radiation is particle. So after some time, they came to a conclusion. What conclusion? That electromagnetic radiation possess dual nature. Electromagnetic radiation is not just wave, not just particle. It possess both of the particle as well as wave nature. This is what dual
So
nature of
it's both
electromagnetic radiation.
continuous and discontinuous.
Ah, yes. It will depend on the phenomena that we are studying. If something needs it to be continuous, it will convert itself into continuous. If something needs it at discontinuous, like as per the requirement, it has dual nature. That will be explained further by the Bohr's model. Okay,
Go
that
hers.
we will talk about. How we pronounce it, Bohr or Bohr? I guess
Bohr.
Bohr. Bohr. Okay. Now, if we read it, to explain reflection, refraction, diffraction. These are the phenomena associated with wave. If we consider light as wave, right?
Yeah.
To explain these phenomena, we take electromagnetic radiation as wave. Whereas to explain photoelectric effect, Einstein considered it to be made up of tiny particles called photons.
Einstein.
Einstein. Am I
Einstein, no?
Einstein? Sure.
Y-
Okay. So Einstein considered it to be what?
Um, to be particles.
Okay. Now, in other words, what we can say, light is a kind of radiation that exhibit dual nature, matter as well as particle. And this is
Okay.
what dual nature of radiation.
Where did
Now we will
matter come from? Matter or waves?
matter particle basically.
Okay.
So radiation has what? Dual nature, particle as well as wave. Is it clear?
Okay. Yeah.
Now from here we will be going into the quantum mechanics a little bit. Okay. Before that, let us talk about spectrum. You must have your doubts about how something is continuous and how something is discontinuous, right? So after this,
Yeah.
those will be clear. So first of all, what is spectrum? I told you, I guess, spectrum is a range of distribution of wavelengths, frequencies, or energy associated with the electromagnetic radiation,
Yeah.
right? Spectrum is
Based on
divided
colors.
two types, based on nature and based on origin. Based on nature, continuous or discontinuous. We have several names for one thing. We can call it discrete, we can call it discontinuous,
Mm.
we can call it line. All of them have same meaning. Based on origin, we can classify it into emission and absorption. Right. So let us talk about them one by one. What is emission spectrum? What do we mean by emission? Emission is when something is emitting something. So spectrum of radiation emitted by a substance that has absorbed energy is called emission spectrum. Suppose, hmm, do you know how bulb works?
Yeah. The filament gets heated up under a nitrogen gas,
Mhm.
which emits light.
So what is happening? That filament is absorbing some energy.
Yeah. But
After
from
absorbing
current.
from current, and after absorbing, it is emitting that energy into visible region. That's why we are
Yeah.
able to see light, right? So if that bulb is emitting some radiation, we will consider it in emission spectrum basically, right? So
Okay.
what is emission? If something is emitting light basically, glowing bulb, sun rays are example. Emission spectra is of two types, continuous and discontinuous. What is continuous? See, while you pass a pass a white light through a prism, it got split into seven colors, right? And
Yeah,
those seven colors are so continuous that they appear like they are merging with each other or not. If I am seeing a rainbow, the colors are so continuous that it appears like the all the colors are merging with each other, right?
yeah,
So if we are getting a spectra where the colors are so continuous that it appear that they are merging with each other, then we will call that spectra as continuous spectra. So try to give it a read to this definition, and if there's any point that you are not understanding, ask me.
okay. What happened to those notes that was written neatly?
Uh, I had to add extra things in those notes. These stuff was not there, so I had to write it on my own. Is it not understandable?
It's understandable.
Okay, try
Yeah.
to read.
Uh, Read.
Your writing is going to look like mine. Don't worry. Just give it few months or years.
Yeah, I understood.
Okay, try to explain it to me. If you understood.
So a white light coming from a source is passing through a prism and dispersed as seven different colors. Okay.
Okay, good.
Um, those are Vibgyor, we can say.
Mm-hmm.
Um, the highest the highest the color that has highest frequency is
Mm,
violet,
good.
and the color that has least frequency is red.
All right.
Um, then these colors are continuous. It's so continuous that it merges together.
And if they are merging together, if they appear to like so continuous, like it, if they appear like they are merging with each other, this type of spectrum is called continuous spectrum, right?
Mm, yes.
So I have already write this. Show a smooth, unbroken range of wavelength. We write smooth like this or not? Should I
Yeah,
use
we
one O
write
or double O?
smooth like that.
Okay. So now let us talk about discontinuous or line spectra. So the opposite of continuous, it will contain some gaps, holes, or breaks in terms of the wavelength. Suppose I have a spectra. This is my spectra. Uh, I have one yellow color, right? If I have a spectra which is discontinuous, then how would it appear? It will have a yellow color, then suppose it has a
Green
green color,
color.
and between these two colors, they are not merged. There will be a break, like a black kind of thing, right?
That's all drawings look like. Yeah.
Uh, so like they have breaks, not continuous. They are separated by these black region, or this black region could be in terms of dots. So if we are having anything which is not continuous, we will put that spectra into discontinuous spectra, right?
How? Wait. Can you explain it again? Because I thought spectrum is continuous.
No, spectrum is not continuous. Spectrum is continuous as well as discontinuous. The continuous spectra is this one.
The
Do you
prism
know?
one.
Huh. If we talk
Then
about
discontinuous
discontinuous,
one.
the actual spectra that we observe while study the atoms. Suppose you are studying an atom. You are studying hydrogen
Okay.
atom, right? You are
Mm.
passing a light through hydrogen atom. So
Yeah.
hydrogen atom won't give you a continuous spectrum. It will give you specific lines separated by a certain gaps or holes. Suppose we are talking about hydrogen spectra. It will give you a specific ordered type of lines. Yellow line, black, green, two dots, black, specific type of lines, right? Lithium will give different, hydrogen will give different, oxygen will give different.
Mm.
If suppose all of these atoms were given, will be giving a continuous spectrum, then you won't be able to differentiate them or not. If all of them are giving continuous spectrum, how will you be able to differentiate the atoms? You won't be able to study them. The
Yeah.
they give discontinuous spectrum.
Otherwise,
That's the
all the
reason.
atoms will be like merged together. It will look
Yeah,
like it
exactly.
merged together.
You won't be able to study them.
Yeah. So it should
So
be
this
discontinuous.
great, great.
It's discontinuous. Or
Right?
in nature, is it continuous and we are making it discontinuous?
No, no, no. You are just passing the light through it, and it is giving you
Okay.
the spectrum. Suppose, uh, once you go into the higher classes, now you will understand what is actually happening while we pass through light. That's a different branch of science, like spectroscopy. There we study different type of spectroscopy, NMR. You must have seen that MRI machines, right? MRI machines.
Yeah.
There we use NMR, nuclear magnetic resonance. It's a part of
Mm.
spectroscopy. Like, and that's a whole different branch. So for now, you can understand it like all atoms give different spectra, because if we go into that now, that will be very complicated for you.
If we pass a light through an atom, it gives a discontinuous spectrum.
And every atom gives a different spectra.
Yeah.
Okay. Now, as we
What's
studied
CD?
emission, CD, like normal cassette CDs,
Okay, okay, okay.
they have discontinuous spectra. That's why we are able to like convert it into, you know,
Mm.
music and all stuff. Now, absorption. What is absorption spectra? When white light is passed through a vapor of a substance and the transmitted light is allowed to strike a prism, dark lines appear in the otherwise continuous spectrum. This is called absorption spectrum. Suppose you have a prism, and now
Mm.
before passing the white light through the prism, you are passing it through a salt solution. While this
Salt
white light is
solution.
salt solution, while this white light is passing through a salt solution, some of the components, some of the wavelengths will be absorbed by this salt solution, and some will be like what we call it,
Dodges away salt
uh,
particle.
uh, like passes without any interaction, right? And those
Yeah.
wavelengths will strike to the prism and they will be separated, right? And here we will again observe a discontinuous spectra. And why this discontinuous
Okay.
spectra is appearing? Because we have inserted a salt solution. Otherwise, it would
So
be
this
continuous.
is kind of a
Absorption.
way to do it at home then.
Like you won't be able to do it at home. How you are going to study the spectra? You can do this. You do this. Like you can bring a salt solution. You can bring us prisma. But how you are going to study this? We have instrument to study this now. You can do it in
Oh,
your lab, but not at home.
okay.
Right now, one of my students got asked this question in their exam, so you should remember what is spectroscopy. The study of emission or absorption spectra is referred as spectroscopy.
So study of emission of
Emission or absorption
absorption of
spectra
spectra.
is referred as spectroscopy. Or
Okay.
to define it even simpler terms, you can say what is spectroscopy? The study of interaction of matter with light is spectroscopy. But in your
Mm.
NCRT, they have written it like this. So use this one to get better marks. Okay.
Mm. Okay.
Right. So I think we should stop here. From tomorrow, we will go into the red box and NCRT questions. Okay. Do you have any questions still here?
From tomorrow? You mean day after tomorrow or tomorrow?
You have your class tomorrow, Tuesday, yes?
I mean, I'm okay for tomorrow.
You
No,
have
actually,
like,
I'm not okay. I have exam at Thursday.
okay, because we missed the class in the last week now. So I was planning to take that class tomorrow.
Yeah, I'm sorry, but I have exam at Thursday.
So like, if not tomorrow, then when? We have to take a class this week because we have exam now. Not
Thursday,
tomorrow,
no.
then Thursday we have a like class, usual class. The class we missed on the last week, we have to take
Oh,
that
yeah,
extra
yeah,
class.
yeah. Extra class. What about Friday, Saturday, Sunday? Any of those days?
Saturday, Sunday, I have classes with other students. On Friday, I think the company don't work. Let me ask. On Friday, if I can arrange a class, then I will take a class on Friday. You are free on Friday, right?
Okay. Yeah,
Okay, I will ask them for a Friday class.
tell
So
me
that's
on
it for today.
evening times.
Yeah, yeah, sure, sure, sure. So do you have any doubts, Leah?
No.
That's it for today. Try to revise it. Otherwise, it would be too much and you won't be able to
But I'm still wondering why you're taking a right to left in
put
quantum.
black
I
body
mean,
radiation.
yeah, no, below that, below that. Yeah, black body radiation.
See, s- suppose you are saying we should take it from left to right, right? If you are
Mm,
moving from left to right, try to take it that way. As I'm
okay.
moving from left to right, the temperature is
Mm,
decreasing.
yeah.
As the temperature is decreasing, the wavelength is increasing and the energy is also decreasing. Right?
Oh, okay.
You can go in both ways. But while the scientists were studying this, they took that approach because that approach is quite simpler to understand. Because
Okay.
if you are moving from right to left, the intensity is increasing.
Yeah, it's easier to study about the proper nationality,
Hmm. Try to revise it.
proportionality.
Hmm. Proportionality. Okay. Try to
Yeah.
revise it
Yeah.
and bring doubts in your next class. Try to do questions.
Okay.
That's it for
And
today. Hmm.
yeah.
If you have questions, you can ask.
No, it's kind of difficult, but it's not about studies. Yeah.
You can ask me, like, if you have any other doubts, you can ask
No,
me.
I was gonna ask to message me the timing if
For
there
Friday
is a
class,
class. Yeah,
I
if
will,
there is a class.
uh, we will let you know by tomorrow. Yeah, by tonight itself.
Yeah.
Okay. Your preferred timing
Okay.
would be
Evening is fine. Evening.
around what
Morning
time?
I'm busy. Uh, Around like 3 to 5 or more than that.
Will the same timing as today will work?
Hmm.
Okay, sure. Then I will. Okay, that's it for today. Thank you.